Okay, look at this entire thing again and tell me how many of you got the same value or the same magnitude of the energy. So all those who have got the same value of the energy, that is 400 microjoule, congratulations, your answer got wrong. Okay, because you have not focused on the thing that I have just explained a bit moment before. What? If I say that this is wrong here, what is the reason? Because if it is having a minus 20 and plus 20 microjoule energy, that doesn't mean that it is not having any energy. If this is having a charge there, so energy must have been stored. So 200 minus 200, it is equal to 0. It is equal to 0. Do you really think that this condition, at this particular condition, the value of the heat loss is 0? How many of you think that the heat loss is 0? According to the theory, yeah, even I agree that the heat loss should be 0, but that is the main thing here. This is wrong. This is what? This is wrong. How can I say that this is wrong? The heat loss cannot be 0 because the current is flowing at this particular point. If the current is flowing through the resistor, definitely heat will be lost here. Are you getting this? Okay. So instead of this, how can I solve this? Well, what you have to understand from here, that the 400, the energy stored in the capacitor that I am telling it is 200. So this 200 is actually not the one that has been present it from the onset of the condition. Okay? Let us say that now it is plus 20 and minus 20. Okay, I have calculated the work done by the battery 200. So is it from the starting position from 0 to 20? Sorry, from 0 to 40? No, the work done by the battery is not from 0 to 40. So how can I compare it with the total energy stored in this? I will have to calculate the change in energy. Okay, what I will do, first I will find that at when it has gone from 0 to 20. Okay, basically the work done by the battery to bring it from 20 to 40 microcoulomb, this is 200. So find the energy of the capacitor when it was at 20. Okay, that energy will be subtracted from the total energy of this, and then it can be compared. Are you getting this? Okay, therefore I will say that here the initial energy plus the work done by the battery, this is equal to the final energy plus the energy loss. Is that clear? Okay, the initial energy, what is the initial energy? I can say initial energy is q square by 2c, simple as that. So 20 into 20 upon 2 into 4. Okay, this will give me value 5, this will give me a value of 10. So I can say initially it was having 50 microjoule energy. So 50 microjoule of earlier plus the work done, that is 200 microjoule. Okay, 50 plus 200, this is equal to the total energy present there. So the total energy is 200 plus the energy lost. So you will find that the energy lost here, this is equal to 50 microjoule. 50 microjoule must have been lost in this particular case. Got it? I hope you got this, that 50 microjoule energy must have been lost in this particular condition. Got it, everyone? So if these kinds of questions are there in front of you, please be confident enough to answer them. Okay, these are generally very easy questions. Okay, I hope you got this right. Okay, if you got this right, let me take the next question. So, okay, the next one. The next question is, okay, I think this question is not needed to be discussed. Okay, no problem. Well, we can have a discussion on this. Let's say that this is the resistance R here. Okay, this is the capacitor. Now this is connected here like this. Okay, this is your plus 20 microcoulomb, this is your minus 20 microcoulomb. Okay, after a while, okay, yeah, the capacitance of this is given as 4 microfarad. 4 microfarad is the capacitance here. Okay, the EMF of this is equal to 10 volt. Okay, the key has been closed, key is been closed. Then what you have to find? You have to find that what is the total energy lost here. Energy lost here is how much? Okay, so I think this is a question given to you. You have to find that at a steady state, what is the total energy lost in this whole process. Okay, I think this is a good question. Pause and try this yourself. I have already given you a hint of this question just a few minutes before, so that will not be a hard question for you. Let me solve it. So this is the resistor, this is the capacitor, this is the battery here, and let's say the circuit has been finally connected. So what is here? This is the higher potential, this is the lower potential, but still at the initial condition 20, the charges were opposite. So when the time lapse will continue, steady state will be observed, and at that steady state, positive microcoulomb will be toward the positive plate and negative 20 microcoulomb will be toward the negative plane. Okay, got it? Now the capacitance is mentioned as 4 microfarad and the whole of 10 volt potential difference will be across this. Okay, but remember why it will be minus 20 and plus 20. I will say here, hear me out carefully, I will say that this will be equal to 40 microcoulomb. So at a steady state it is not 20 and 20, it is equal to minus 40 microcoulomb here and plus 40 microcoulomb here. Any doubt in this? I hope you got this. Perfect. So this is the direction of the flow of positive charges. Okay. What is the entire scenario here? Can you tell me what is the total charge transfer that has taken place? So total charge is final charge minus the initial charge. What is the final charge? Final charge is 40 microcoulomb. What is the initial charge? Initial charge was minus 20 microcoulomb. So 60 microcoulomb charge has been transferred. Yeah. First it went from plus 20 to 0 and then from plus 20 it went to minus 40. So yeah, this is equal to 60 microcoulomb total charge has taken place. So what is the work done by the battery here? Well, you will find that the work done by the battery is the charge transfer multiplied by the EMF here, which is equal to 60 microcoulomb into 10, that is equal to 600 microjoule energy. So 600 microjoule energy has been present here. of which what is the energy stored in the capacitor? The energy stored in the capacitor is equal to half CV square, that is equal to half into C, that is 4, into V square, that is 10 square. So this will give me a value of 200 microjoule. So the battery has done a work of 600 microjoule, but still the energy stored in the capacitor is 200 microjoule. So what is the value of the energy lost here? So you will say that energy loss is equal to 600 minus 200. This is equal to 400. This is equal to 400 microjoule. So 400 microjoule energy has been lost. Okay, how many of you got the same answer? Okay, look at this entire thing again and tell me how many of you got the same value or the same magnitude of the energy. So all those who have got the same value of the energy, that is 400 microjoule, congratulations, your answer got wrong. Okay, because you have not focused on the thing that I have just explained a bit moment before. What? If I say that this is wrong here, what is the reason? Because if it is having a minus 20 and plus 20 microjoule energy, that doesn't mean that it is not having any energy. If this is having a charge there, so energy must have been stored. So first calculate that what is the initial energy possessed by it. Okay, then I will write that the initial energy possessed by plus the work done by the battery, that is final energy plus the energy lost. Okay, so what is the net condition here? I will say what is the initial energy? So that is q square by 2c. So 20 into 20 upon 2 into c, that is 4. 2 into 4, this is equal to 10, 5. So this is equal to 50 microjoule. 50 microjoule energy has been already present there. So 50 plus the work done, that is 200. Okay, sorry, 600. This is equal to 400 plus the energy loss. So the energy loss here is equal to 450 microjoule. The energy loss is equal to 450 microjoule. Is that clear, everyone? Okay, I hope you got the answer. Okay, you know what, still many of you think that here since the negative, since the polarity of the charges are reversed there, so this should be minus 50 microjoule. No, it should not be minus 50 joule, because this is basically the energy stored in this and the energy is there to be the positive. So this should be kept as simply plus 50 only. Okay, so the correct answer to this question, energy loss, is 450 joule. Got it, guys? I hope you got this question. Okay, if you got this question, then do one more. The next question is this. Question says that the capacitor of capacitance C charged with potential 2 volt by the battery, then battery is removed. Okay, now the battery is removed. Now other battery of EMF we connected to this charge capacitor, okay, with opposite polarity. Okay, so then find the loss of energy loss in the circuit. Okay, this is a good question. Okay, try to find that what is the energy loss in this particular circuit. Pause the screen and try this. Okay, let me give you the condition that this is the capacitor, this is the battery. The battery was having 2V. Okay, here firstly it has been connected, it has been left for a while. After that the battery is now removed. Okay, and now it has been connected to another one with the potential difference of V with opposite polarity as well. Okay, so earlier it was like this and now it is like this. Okay, so I think that's a good question, guys. Okay, try this question. Okay, let us say that the capacitor is C. So finally, I am talking about the final stage. The potential difference across this will be 2V. And what is the value of the charges? The charges will be 2 plus 2CV minus 2CV, right? Due to the polarity of this. So here right now I am having plus 2C charge, CV charge, and this is minus 2CV charge. Okay, fine. Now when finally, now the capacitor is still the same. The potential has been V. Now what is the value of the charges at the steady state? At steady state, you will find that now since the polarity has also been reversed, here we are having plus CV and here we are having minus CV. Okay, this is the charges across the capacitor. So what is the total charge transfer that has taken place? So it has been from plus CV to minus CV, that is equal to 3CV. 3CV charge has been transferred in this particular condition. Okay, 3CV charge has been transferred in this particular condition. How to find out the energy loss? So remember the simple formula. I know you will not miss this formula now. That energy initial plus the work done by the battery is equal to energy final plus the energy loss. Okay, simple. So I can say from here that what is the initial energy? Initial energy is equal to Q square by 2C. So this is equal to Q square. What is the value of Q square? So 4C square V square by 2C. So this is 2, this is C gets cancelled. So I can write 2CV square. This is the initial energy. What is the final energy here? So the final energy is basically how much? I can say final energy is basically Q square by 2C again. So Q square, that is.
The problem is not effort. It's lack of personal attention. With one-to-one mentoring, every doubt is addressed, every concept is applied, and real improvement begins.